Hello online viewers, welcome to our lecture video. In this lecture video, we are going to talk about LU decomposition method. What is LU decomposition method, under which conditions we are going to use the LU decomposition method, and how we are going to solve using LU decomposition method. I have already created several videos on how we can solve your equation using the bisection method, Raphson method, iteration method, false position method, and many more, whose link you can find in the description box below. So right now, let's talk about LU decomposition method. So as you can see here, I have a system of linear equation. I have here a11 x1 plus a12 x2 plus a13 x3 equals to b1. We have x1 x1 x2 and x3, three variables, and we need to solve this by LU decomposition method. So what are the conditions to solve? What are the criteria for our equation to be solved by LU decomposition method? So firstly, let me write this in the term of a matrix. So I'm going to write this as let A equals to, I'm going to write down the coefficient matrix a11 a11 a12 a13. Now we are going to write our elements of second row, which is a21 a22 a23, and similarly a31 a32 a33. So our one and only criteria for using LU decomposition method is that our matrix A, this must be non-singular square matrix. Non-singular square matrix. So what does this mean? Non-singular square matrix. So for this matrix to be non-singular, the determinant of A must not be equal to 0, and for it to be square matrix, the number of rows and number of columns must be equal. So as you can see over here, we have 3 number of rows and 3 number of columns, so it is a square matrix, and the determinant of this is also not equal to 0. So we can use LU decomposition method for this equation. Now after knowing that our matrix follows the criteria for LU decomposition method, what we are going to do next is we are going to factorize A. We are going to factorize A in the form of LU. A equals to LU. So what does L means? L means a lower triangular matrix, and where L is, so let me write it down over here, where L is a lower triangular matrix, lower triangular matrix, and U is a upper triangular matrix, and U is a upper triangular matrix. So as you can see here, the name LU decomposition method is derived from here only. We are going to set LU A equals to LU, so LU decomposition method comes over here. So let me write L and U. So what is a lower triangular matrix and what is a upper triangular matrix? So for a lower and upper triangular matrix, what we are going to do is, so let me write down the elements of diagonal element firstly: L11, L22, L33, and U11, U22, U33. So as you can see here, for a lower triangular matrix, it will have the elements below the main diagonal only, below the main diagonal, and in the main diagonal will have elements, while in the upper diagonal it will be filled with zeros. Similarly for upper triangular matrix, vice versa, in main diagonal and above the main diagonal we are going to have our elements u22, u33, u23, while the below the main diagonal, in upper triangular matrix, below the main diagonal, lower of the main diagonal, we are going to have 0, and this will be filled by L21, L31, and L32. As you can see here, just the vice versa. In a lower triangular matrix, we will have 0. All the elements above the main diagonal will be 0, while in upper triangular matrix, all the elements below the main diagonal will be 0. So exactly vice versa. So now over here we are going to get in our question such as LII equals to 1, or we are going to get sometimes UII equals to 1. So what does this mean is, in our main diagonal we are going to place 1 1 1 if we are given this condition in our question, and if we are given UII equals to 1, we are going to place the value 1 1 1 in our U11 over here. U11 over here. So that's the so I'll explain this furthermore when we'll do a example. When we'll be doing an example, this will be more clearer. Now in the next step, what we need to do is, we have A equals to LU. So let me name this as equation A. What we are going to do is, we are going to equation 1. This is our equation 1. We can rewrite our equation 1 as equation 1. We can rewrite it as rewriting this. We can rewrite equation 1 in such a format such A. So our A is this, we are going to write a x equals to b, ax equals to b, where as you can see here our a is this, so I'm not going to write it down over there. Our x will be equal to x1, x2, x3, and our b is going to be equal to b1, b2, b3. So we're not doing anything more, we're just writing this equation in the form of ax equals to b. Now in next step what we're going to do is, we have a value as LU, so we're going to substitute LU x equals to b, LU x equals to b. This is going to be our equation b. So what we're going to do next is, we're going to set ux equals to y, where y equals to y1, y2, y3, and from here we are going to find the value of y, and we are going to, after knowing this value, we are going to substitute it back in equation b, and we are going to get ly equals to b, from this we are going to find out the value of b. So now what we're going to do is, we are going to solve this equation. We'll be solving this equation by forward substitution. We will solve this equation by forward substitution, and we'll obtain the value of y. And after knowing the value of y, we are going to substitute it over back in this equation. In the equation ux, let me name this as c, let me name this as d. From d we'll find the value of y. We'll substitute it back to c, and we'll find the value of x. So knowing the value of x, our equation will be solved. It seems a little bit confusing seeing ux, ly, and etc. over here. Once you do a demonstrative example, it's going to be a lot simpler. So now to our example, we are going to solve this by LU decomposition method. So firstly what we are going to do is, we are going to write everything given. So we have our equation x plus 2y plus 3z equals to 14, and other similar equations, and we have been given here Lii equals to 1. So as I talked before, we are going to be given certain conditions in our equation, either Lii equals to 1 or Uii equals to 1. UYI. So right now we have been given LII equals to 1. So what does this means? It means that the our main diagonal of lower triangular matrix is going to be 1 1 1. If this was given, what this meant was, our elements of main diagonal of upper triangular matrix is 1 1 1. So let me write down firstly the given portion. Given that A equals to, so let me simply write down the given things. Given that A equals to 1 2 3, simply write down all the coefficients: 1 2 3, 2 20 26, 2 20 26, 3 26 70, comma B equals to, our B is going to be x y z, x equals to x y z, comma B equals to, our Ax equals to B. B is our D1 14 120 265. So firstly we write this much, and after writing this, what we are going to do is, we are going to write where Ax equals to B. So as I explained before, we are going to write this equation in the form of Ax equals to B. Now we are going to name this as equation 1. Now we are going to factorize A in the form of A equals to LU, where, as I explained before, L is lower triangular matrix. So as I explained, right now we have been given the equation Lii equals to 1, which means our main diagonal, elements of our main diagonal is going of lower triangular matrix is going to be 1 1 1. So the upper everything is going to be 0. So remaining is L21, L31, and L32, comma U equals to U21, U22, U33. So right now we haven't been given the condition Uii equals to 1. If we were to give the condition Uii equals to 1, we will write 1 1 1 simply over here. The main diagonal would simply be 1 1 1, and now all the elements below are 0, and and this is equal to, so this is U11, U11, U12, U13, U23. So that is it. Now we are going to simply substitute the value. We have the value of A, which is 1 2 3 2 20 26 3 26 70, and our value of L is, we are simply substituting in over here in this equation. we're substituting the value. We have L is 1 0 0, L21 1 0, L31 L32 1, multiply U11 U12 U13 0 0 U22 0 U23 U33. So as explained before, our one and only criteria for LU decomposition method is that our matrix A must be non-singular and square. As you can see, it is 3 by 3 matrix. If you calculate its determinant, it is not equal to 0, so we can solve it by LU decomposition method. And now we need to do the do this multiplication, matrix multiplication. And on doing this, we need to multiply our row with first column. So multiply 1 times U11, this will be equal to U11 plus 0 times 0 0 plus 0 times 0 0. Now we need to multiply this row and this second column, and we get this as 1 times U12 is U12 plus 0 times U22 is 0 plus 0 times 0 is 0. Now again multiply your first row and third column, then we'll get this as 1 times U13 plus 0 times U23 0 0 times U33 0 plus 0. Now our second row must multiply the first column, L21 times U11 times U11 plus 1 times 0 is 0 0 times 0 is 0. Again second row second column, L21 U12 plus 1 times U22 is U22 plus 0 times 0 is 0. And again second row third column, L21 U13 plus U23 L21 U13 1 U23 0 times U13 is 0. So now for our last row, third row first column, U31 U11 plus 0 0, L31 U12 plus L32 U22, 1 times 0 is 0, so plus 0, and this is going to be L31 times U13 L31 times U13 plus, I'm going to write it down over a little bit, so L32 times U23 plus 1 times U33. So this is our matrix multiplication, and we need to equate the corresponding elements. So let me simply write over here, equating the corresponding elements. So we're simply going to equate the corresponding elements, equating the corresponding elements. What we're going to get is this is going to be U11 equals to 1, U11 equals to 1, comma U12 will be equal to 2, U12 equals to 2, comma U13 will be equal to 3, equals to 3. Now let's move on to our second row. We get L21 U11 equals to 2, which means we have our value of U11 as 1, and we get L21 as 2, comma L21 U12 plus U22 equals to 20. So we have our value L21 is 2 into U12 is 2 plus U22. On solving this, we get our value of U22 as 16. And similarly for our third element, we get L21 U13 plus U23 equals to 26. So we get L21 is 2 into U13 is 3 plus U23 equals to 26, which means U23 equals to 20. And now we move on to our third row. So we get L31 U11 equals to, this is equal to 3. We have our U11 as 1, so L31 will be equal to 3. Similarly, L31 U12 plus L32 U22 equals to 26. So let me directly write down my value over here. On solving and substituting the value, we are going to get L32 equals to 5 by 4. And similarly for our final, L31 U13 plus L32 U23 plus U33 equals to 70. So I'm directly writing it down, and solving this, we are going to get U33 equals to 36. So let me write down my final. So let me simply write it down over here. Therefore L equals to 1 1 1 0 0 0, comma U equals to So let me write down L21. Our L21 is 2, L31 is 3, and L32 is 5 by 4. So we have got our lower triangular matrix, and for our upper triangular matrix we got 0 0 0 over here. We have U11 is over here 1, U22 2, U23 3. Then we got U12 is 2, and U13 is 3. We got U22 as 16. We got U23 as 20, and we got U33 as 36. So we are simply writing down the values we calculated. Now after knowing this, we are going to move on to our second step. So now as you can see over here, we have ax equals to b from our equation 1, and we set a equals to lu. So if you substitute lu over here, we are going to get lux equals to b, and now what we are going to do is so if we set ux equals to y, what we are going to get is we are going to get ly equals to b. Now we are going to name this as equation 3. This is going to be our equation 2, this is going to be our equation 3. Ly equals to b. Now I'm going to write my lower triangular matrix which I calculated before. So 1 1 1 0 0 0. So I have already found my L, which is this one. I'm going to write it over here, which is 2 3 5 by 4. Now my y is nothing more than y1 y2 y3, and my substitute my value of L over here, and my value of y is y1 y2 y3. And now my value of b, as I have already said before, my value of b is 14 120 265. So I'm going to simply put that, nothing new, 14 125 265. Now we are going to solve this matrix. So we are going to solve this by forward substitution. Solving by forward substitution. So what does forward substitution mean? Forward substitution simply means we are going to solve it from top to bottom, which means firstly we are going to find the value of y1, then y2 and y3. So what we are going to do is, if we multiply this first row and first column, we are going to get y1 equals to 14. Second row, same column, we get 2y1 plus y2. 2y1 plus y2 equals to 120. So I have my value of y1 as 14, and if I substitute this, I'm going to get my y2 value as 92. Similarly, my third equation will be 3y1 5 by 4 y2 plus y3. 3y1 plus 5 by 4 y2 plus y3 equals to 265. Substituting the value of y1 as 14 and y2 as 92, I'm going to get my value of y as 108. So after doing this much, therefore, so let me write it over here only. Therefore y equals to 1492 108. So this is my value of y. Now what I'm going to do next is I'm going to use equation 2. From equation 2, I have ux equals to y. So my u is upper triangular matrix equals to y. So I have my y value as 1492 108. Now my x is going to be x1 x2 x3. So as you can see over here, my x is xyz. My x is xyz. So okay, so we're going to name this as xyz or x1 x2, it doesn't matter. So following my question, I'm going to write it as xyz. And now my u is over here 1 2 3 0 16 20 00 36, which is calculated before. We are going to simply substitute it over here. So 1 2 3 0 16 20 and 00 36. So now we are going to solve this by backward substitution. Solving by backward substitution. So as vice versa of as that of forward substitution. In forward substitution, firstly we calculate the value of y1 y2 and y3. We are going to go from down to up. Firstly we are going to find the value of z, which is equal to be multiply this and this. 0 times x 0, 0 times y 0 plus 36z, which means 36. So this is 0 times x plus 0 times y plus 36 times z equals to 108. So z will be simply equal to 3. Similarly, this multiplication, which is now we move on to 16y plus 20z. 16y plus 20z equals to 92. Solve this, we get your value of y. Substitute j as 3, we get y value as 2, and for final x plus 2y, x 2y 3j plus 3j equals to 14. On solving this, we are going to get our x value as 1. Therefore x y j equals to 1 comma 2 comma 3. So finally we calculate our value, and if we want to check, if we move on to our equation, if we put x as 1 plus 2 2 4 5 3 3 9, so we get this as 14. So you can check your answer this way as well by substituting in the initial equation. So in this way, by using LU decomposition method, you can solve your equation. Hope this video was of help to you, and if you have any queries, you can comment down below, and if you like the video and if it was any help to you, do subscribe the channel. Thank you.